Okay, this is a continuation of section 8.1 for MAC 1114, problem number 14. So in this problem, they describe an aircraft that leaves an airport from a runway bearing a northeast 29-degree direction. So that's the path that it's traveling on, and I'm going to draw this for you in a diagram so you have a visual on these words. After flying for a quarter of a mile along that path, northeast 29 degrees, the pilot requests permission to make a 90-degree turn and head toward the southeast, and permission is granted. After the airplane goes 1 mile in this direction, what bearing should the control tower use to locate the aircraft? In other words, where does the aircraft end up when all of this is said and done? After it takes off on the two paths that have been described in the problem thus far, where does it end up? What direction, between what two directions is it? And how many degrees would you have to rotate from the air control tower in order to locate the airplane? So here's a nice picture for you. We can work it out right here. And again, I'll go over the words that were in this problem. Okay, first thing you need when you're going to do a problem with directions is you need to have a north and a south. That would be your vertical pole, and then a west and an east, which would be your horizontal pole. And then you'll have your four directions. So again, the wording was the plane takes off from the airport will be at the origin, because then you can measure from that origin north, south, east, and west. If you go up, it's north, south. If you go this way, it's west, and so forth. That's why it has to be positioned at the origin. So it says that the plane takes off bearing a northeast 29-degree direction. So when they give you information like that, it means that it was pointed in the north direction and then rotated 29 degrees towards the east direction. So that means from here to here is how it rotated. It started off like this, rotated towards the east direction, 29 degrees. Okay, so we have an angle that's on the outside of the triangle that we're working in. It says that this path of northeast 29 degrees, that it travels for a quarter of a mile along this path right here. So I'll put quarter of a mile. 1/4 is the same thing as 0.25. Okay, once it travels for a quarter of a mile along this northeast 29-degree path, it requests permission to make a right turn. So right there at the end of the quarter mile, it requests permission to make a right turn, and now it's traveling towards the southeast direction. So now the plane ends up between the south and the easterly direction, and it travels along this path for 1 mile, it says in the problem. So you're using things that are described in the problem to label a right triangle. Okay, now in order to go from having angles that are on the outside of a triangle, which is a very common thing for them to throw at you, so that you're using not only the trig that you have learned, but also the geometry that you've learned, which has been going on for the entire course. We're in the 3rd chapter now. So this 29 degrees is going to ultimately help us to get this. See, in the end, they want to know, this is where the plane ends up after it travels along the two paths that have been described. Quarter of a mile at a northeast bearing of 29 degrees, that's this path. This path is between the north and the east pole, and 29 degrees from the north to the east. Then it goes on this other path, which is in a southeast direction for 1 mile. So ultimately it ends up here, and we want to know, if you're at the air control tower and you're trying to put your sights on that plane, how many degrees would you have to rotate in order to be on this same path that the plane's on? Then you'd be able to locate it. So this is really the angle that they want, and we're going to have to go through a couple of steps in order to get to the answer. All these problems, 13 through 16, are multi-step problems using geometry and trig. Some of them you have to draw, some of them you don't. Now, I would look at the problem to see what they want you to round to. Ultimately, at the end, you're going to be rounding to the tenths place. I don't think I would round to the tenths place as you're doing the steps in between, but the final answer has to be round to the tenths place. I would hold on to a few more decimals than that just for accuracy in your final answer. Okay, so moving into this triangle. What I could do as far as geometry goes is I could use the fact that these three angles right here add up to 180. That is half of a circle, 180 degrees. There are three portions, three angles contributing to that 180 degrees. 29 degrees, this theta, and I just happen to call it theta. You can call it anything you want. You can call this anything you want. As far as an angle name goes. So the three portions contributing to this 180 are 29, theta, and beta. I'm going to go inside the triangle, use my trig, and find theta first, and then go and use geometry, that these add up to 180, to ultimately find beta. So let's see, how would I go about finding theta? I could use this one that they've provided for us, and I could also use the 0.25. Now the names of these pieces of the triangle with respect to where I'm standing on angle theta. This guy right here is called opposite, and this leg right here is called adjacent. So thinking in terms of trig, the trig identity that you learn that incorporates opposite and adjacent would be tangent. So my first step, I'm going to do tangent of the angle that I'm standing on. This is the definition that I'm using. The opposite is the 1 mile, and the adjacent is the 0.25 miles. Those units cancel, leaving me with tan of theta is equal to 1 divided by 0.25. You can put that in your calculator if you'd like, and that's equal to 4. So if I want to find theta, then I have to do inverse. You find angles by doing the inverse. Inverses are written by switching these two. So inverse of 4 is equal to theta. And if you want that in degrees, make sure that your mode is in degrees. I'm in degrees. I'm going to quit out of there and press in inverse tan. So second inverse tan, put in the 4, my mode's in degrees, and I'm going to hold on to 4 numbers after the decimal, then round off to the tenths place. Okay, so theta is equal to 75.9638. You can see it right there, 0.9638. Okay, so after I know that, and this is in degrees, 75.9638. Then let's switch over to, instead of trig, geometry. The sum of these is 180. You have 2 of the 3 portions contributing to that 180 degrees. So if you want to do the final answer, if you want to get the final answer, you're going to go beta is equal to 180. Take away the 29 as well as the angle that we just found, which is 75.9638. Okay, put all that in your calculator. 180 minus 75.9638. And you get 104. Oops, I didn't subtract everything. Let me go back and enter that again. I didn't put the 29 in there. So 180 minus 29 minus 75.9638. I had only entered this one number right here. Okay, so now we got it. So now this is 75.0362 degrees. Okay, if we round that to the tenths place, then that would be 75.0, or just 75 degrees. Okay, so there that is. And then when you go and try to fill in the answers as they have left it for you, in problem number 14, they have these blanks that you're supposed to fill in. And you know that for what I was talking to you about right here, that when you give a directional, when you try to give somebody a location, you say what two directionals it's between and how many degrees rotated from the first one to the second one it can be located. So this plane where it finally meets up here, it's between the south and the east pole. And from the south to the east pole, it's a rotation of 75 degrees. So when you go and fill in the answer in my math lab, you're going to put the south here, the east here, and you can check these off, and you can put the 75 degrees, which is the answer, rounded to the 10th place. Okay, so moving on to problem number 15. And in problem number 15, it's kind of an involved drawing, but basically it's like this. I'm just copying the picture to make it bigger so that we have room to work these things out. So you have a side. Now some of these lines are dashed, but that brings no relevance to the problem. You're still going to be finding all of the same things. There's a piece that comes down like this, and they tell you, we'll look at the actual picture in a minute. This is problem number 15. That's 1 mile. And they don't give you anything right here, but if this is 1 mile, this is 1 mile. These are perpendicular, these pieces. So you're coming down at a right angle so that you can work with right triangles on either end. They give you off to the side here 155 degrees. So you have an angle on the outside of your actual triangle that you're going to be working in. They also give you an exterior angle over here of 145 degrees, which you're going to use to work with that triangle. Okay, so the question is, let's go to the problem that's actually you were given. This is what the picture looks like. The only thing I don't have in my picture is the 7 miles, so let's go ahead and put that in. They're telling you, if you don't understand this, that when they put the 7 right there in the middle of these dashed lines, that means from here to here. It can't possibly mean from here to here because these go on and on and on. So this is a definite distance. You're going to use that 7 miles from there to help you find this piece. Look what the question is. In this light color in the middle, that's the bay. They are trying to build a bridge that goes all the way around the bay. Therefore, you're going to need to find this length, and this length. Finding the length at the top, this little horizontal piece, is part of this 7. So the idea here is that when you do go to find the hardest piece, which is that piece in the middle, these will be pretty easy. They're just hypotenuse of the 2 right triangles, the one over here and the one over here. But when you go to find that piece, which you're going to need to find the total distance around the bay that it's going to take to make the bridge, you're going to have to go 7, take off this tail end, take off that tail end. So you have quite a bit of work to do. This is significantly more steps than problem number 14, but I will go into the first part of it where I'm looking for R1. So I'm going to call this R1. I'm going to call this R2. This will be called, I'll call this X1 and I'll call this X2. Again, from here to here is 7 miles. So if you wanted to go find R1 first, you could first of all know that from here to here is 180. 180 take away 155 would be 25 degrees. Just like over here, 180 minus 145, that would give you 35 degrees. So if you're working in here and you want to find R1, it's going to be you're standing on the 25 degree angle. And then in the 25 degree angle,